All right, number 66 now. Once again, distributive property. All right, so let's separate this so that we can work easier. Boom. So we're going to be multiplying this by this, and then this by this, and then this by this, and then by this by this. These little routines in math, these little routines, these come over and over again. All right. 9 times 6b, which is really saying 9 times 6 times b. This is 54b. 54b. 9 times 5, well, that's just regular old 45. Negative 4b times b, which is negative 4 times b times b. And that is minus 4, right, b squared. And negative 4b times 3 is really negative 4 times b times 3, which is, yeah, these minus 12b. Minus 12b. Now, are there any like terms? Well, I got 145 here. I got a 45 right here, but nothing else. I got a b squared here, but nothing else. But I got two b's here. Seems to me I could combine these and turn this into a 42b, right? 54 minus 12. And then plus 45 minus 4b squared. We just bring these down, right? And did I get that right? Oh, I got this wrong. What seems to be the problem? No, I think I got it right. I think it's the... Yeah, I'm pretty sure I got this right. The answer is wrong in the book. So, yeah, because here they're saying they're saying this should be a negative, but it's not a negative. It's 5 times. Am I doing this right? 66. Yeah, right. It's 45. What are they saying? They don't know what they're talking about. This is the right answer. This is the right answer. Am I tripping? They put everything negative. How could everything be negative? No, they're wrong. They don't know what they're talking about. They're wrong. This is the right answer. The book is wrong. All right, number 67 now. That happens sometimes. The book is wrong. 7 times 7 plus 3v plus 10. Hold on, make that 10 better. 3 minus 10v. All right. So once again, let's just make these boxes to help our lives. Boom. 7 times 7 is what? 49, right? 7 times 3 equals 21, right? It's a positive. And this v right here, right there. 10 times 3 plus 30. 10 times negative 10v. So that's really saying 10 times negative 10 times v. So that's negative 100 v. So we got two v's here and we got two nothings here. So we can combine these terms, which will give us 79, right? 49 plus 30. Then we have 21 minus 100, which will give us minus 79v. Is that for real? Am I right? 67, let me see. Yes, I'm right. There's 68 now. 68. So 68, hold on, let me just help myself here. 68 minus 7, 4x minus 6 plus 2, 10x minus 10. Okay, so that's our equation. So once again, we're going to split up the problem in two to make our lives easier. Like that. Minus 7 times 4x equals minus 28x, right? Because this is really minus 7 times 4 times x. And then negative 7 times negative 6 equals positive 42. And positive 2 times 10x equals 20x, right? 2 times 10, and then just tag on the x, so that's a multiplication here. And then 2 times negative 10 equals minus 20. So here we have two x's, and here we have two nothings, just regular old numbers. So negative 28x plus 20x, if we just remove the x's for 1 second, so we can just do minus 28 plus 20 equals minus 8, and we just add the x after. Remember, we're not multiplying, so it's not x squared, we're adding. We're combining like terms, that's what it's called. 42 minus 20, 22, number 68, and I'm right. Moving along to 69. So that is 2n minus 10n plus 5 minus 7, 6 minus 10n. Okie dokie. Let's, same bloody thing. I just box these off. All right. So negative 2n times minus 10n. So that would be 2 times n times negative 10 times n, right? When you multiply, just multiply everything. All right, so we are going to get 2 times negative 10 equals minus 20, n times n equals n squared. So minus 20 n squared. Then 2n times 5 equals 10n, right? 2n times 5. You want to do 5 times 2n, or 5 times 2 bottles, or 5 times 2 birds? Well, you're going to have 10 birds at the end, 10n. Next item up for bid, negative 7 times 6 equals minus 42. That was pretty easy. Minus 7 times minus 10n, which is really minus 7 times minus 10 times n, which is plus 70n. Remember, when you have an even number of minus signs, the whole multiplication becomes positive. All right, what do we got here? We got an n squared. Do we have any other n squared? Nope. We have an n. Do we have any other? Yes. We have a nothing, just a regular old number. Do you have any other regular old numbers here? Nope. So these buggers we can bring down right away. Minus 20n squared minus 42. And then we have 10n plus 70n equals 80n. Is that the right answer? Ooh, 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 ooh. I think it is. Yes, it is. Moving along to 70 now. Only 12 problems left. Actually 13 if you count the 0. 70. Okay, so that's minus 3 brackets 4 plus a brackets plus 6a brackets 9a plus 10. All right, let me just make this a nice a. All right, good. We're ready to rock to solve this guy. What do we do again? Look at what I'm going to do. Isn't this beautiful? Isn't this beautiful? Negative 3 times 4 equals 12. Negative 3 times a equals minus 3a. Oops, where's my mistake? Negative 3 times 4 equals negative 12. I screwed up. I screwed up. All right, now we do the other problem. Positive 6a times 9a. So what they're saying here is 6 times a times 9 times a, which is equal to 54a squared, right? Because a times a equals a squared. And then we have, so we did that. Now we have 6a times 10. So 6a times 10 is 6 times a times 10, which really is 60a. All right, so I see a regular old number. Are there any other regular old numbers here? Nothing. Nothing. I see, so we're going to bring that down right away. Minus 3a, are there any other a numbers? Yes, there is 60a here. So minus 3a plus 60a. If you're not sure, if you're wondering why can we do this, well, if I say minus 3 apples plus 60 apples, then I get 57 apples. So these two are here. This one is there, and we just bring this one down. It's the only one left, plus 54a squared. Does that look right? 70 minus 12, 57A, 54. Yeah, I got that one right too. 71 now. 5, 1 minus 6K. Close the brackets. Plus 10K minus 8. All right, so once again, let's make our lives easy. Boom. Good. Hold on a sec. All right. Okay, so now we're going to look at 5 times 1 equals 5. 5 times minus 6K equals minus 30K, which is 5 times negative 6 times K. All right, so we did that part. Now we're going to do this one. So positive 10 times K equals positive 10K. So we're multiplying, remember, even though we see a bunch of plus and minus signs, we're all multiplying this whole thing. Positive 10 times negative 8 equals negative 80, right? Positive times a negative equals a negative. All right, so can we combine like terms? I see a number here. Are there any other numbers? Yes, I think there's this one right here. So this one could be minus 75, right? 5 minus 80. And then we have these two buggers here. So minus 30 kettles plus 10 kettles equals minus 20 kettles. Am I right? Yes, I am. All right, 72 now. Whoops. 72 it is. Minus 7, 4x minus 6, plus 2, 10x minus 10. Boom. All right, does that look right? 72. Oh, that's not a 6. That's a 3. Oh boy, I wrote this problem all wrong. Let me erase it and start over. 72. So that's minus 7, 4x plus 3 minus 10, 10x plus 10. All right. Okie dokie. So, once again, we're going to do our famous split. That way it's easier to work. Negative 7 times 4x equals negative 28x. Negative 7 times 3 equals negative 21. Negative 10 times 10x equals negative 100x. Remember, it's minus 10 times 10 times x, right? Then minus 10 times 10 equals minus 100. So let's take a look at this. Are there any like terms? Well, these two buggers are the same. Should really say it like that. Then you have these two buggers who are the same. So minus 28 x's minus 100 x's is minus 128 x's total. And minus 21 minus 100 is minus 121. And is that the right answer? Yes, it is. All right, so that's up to 72. I'll write that down. And we're going to continue the next one after.